Okay, so now that we have an idea of how to build electron configurations using our orbital diagrams, we're going to show you a shortcut that you can use to get the exact same answer. And you don't have to memorize that order of filling the orbitals, for instance, orbital diagram that we saw previously. You can just use the periodic table, which you will always have available for a quiz or an exam. And the way that the periodic table is arranged actually corresponds to all of those different sublevels that we talked about, the S, the P, the D, and the F. Right? So there are actually S blocks in the periodic table. There are P blocks on the periodic table. And there are D blocks and F blocks, etc. Right? If we know what to look for, we can actually build those electron configurations simply by locating where that element is on the periodic table. All right, so here your textbook does a good job of showing you where those blocks are. So the S block is the first two columns of the periodic table. All right, and you notice that there isn't actually an element here on the table. It actually belongs over here, which is where helium is, but we move it over just because it makes more sense to put it to complete that S block. And if you recall, right, the S sublevel contains one S orbital, which can only hold 2 electrons. And guess how many rows or how many columns there are? There are 2 columns in that S block. The P block is over here on the right side. And if you remember, the P sublevel has 3 P orbitals, which can hold a total of 6 electrons. And how many columns do we have here? We have 1, 2, 3, 4, 5, 6 columns. So the number of columns actually tell you how many electrons these different blocks or sublevels can hold. In the middle here we have the D block elements. Okay, and if you recall, the D block has 5 D orbitals, which can hold a total of 10 electrons. And you can guess how many columns there are in the D block. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the F block underneath, okay, if you recall, the F sublevels, or the S sublevel, F sublevel, has 7 F orbitals, which can hold a total of 14 electrons. And guess how many columns there are? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 columns. All right, so we can separate the periodic table into these different blocks. We don't have to do anything else with the table because guess what? It's already organized this way. All the elements are found in these locations. All right, so the S block includes the group 1 and group 2 elements and also helium that we stick in there at the end of the first period. The P block we talked about, the 6 columns on the right side of the table. And then the D block, which we also call the transition elements. Or transition metals, because they're all metals in there. There are 10 columns in there corresponding to those 10 electrons that can be accommodated. And then the F block, which we refer to as the inner transition elements. All right, there are 14 of those columns, which correspond to the 14 electrons that the F sublevel can accommodate. All right, so the different regions of the periodic table are going to give us the sublevels, right? But what about the main energy levels, the principal energy levels? Well, those actually come from the periods. Okay, so the period numbers tell us the energy level, the main or principal energy level or shell. So we actually have everything we need to complete our electron configuration using the periodic table. We don't need to draw our orbital diagrams if we have a periodic table handy. So let's take a look at how we can do that, writing our electron configurations just by using the periodic table. So here it says to use the sublevel blocks in the periodic table to write the electron configuration for chlorine. All right, and I'm going to use a typical periodic table. Let me scroll all the way down to one that you would have to use on your quiz or your exam. All right, so first thing you want to do is to find chlorine. So chlorine is Cl, and here it is. Okay, and I'm going to just color code. I'm going to color code our different blocks. So the S block we'll do in green. It's the S block over here. And it also includes helium. Our P block is going to be in yellow. And then the D block we'll do in, this pink color. Okay, and then I'll write in our period numbers. So period 1, period 2, 3, 4, 5, 6, and 7. All right, so what I need to do is to get to chlorine, which is over here. And you'll notice, chlorine has atomic number 17. All right, so that means that there are going to be 17 electrons that I need to account for. So we're always going to start at the top left. Start with hydrogen and work our way across. All right, so to get across that first row, I'm going to start with 1. And then, remember the green is our S block. So I go 1, S, then I have to go 2 elements in to get across to helium. So I go 1, S, 2 to get all the way across to helium. Then I go 2, S, 1, 2 to get to beryllium. So 2s2. And then when I have to go all the way across on the other side, I now encounter the P block over here in yellow. And again, we are in the second period. So we go 2p, 1, 2, 3, 4, 5, 6. Gets us to the end. So 2p6. Then we go down to the next row. We're in the third period now. So 3s, 1, 2. We end the S block. And then we go all the way across. We encounter the P block now. We're still in the third row. So 3p, 1, 2, 3, 4, 5 gets us to chlorine. So that'll be 3p, 5. And that's it. That's how you can use the periodic table to help you figure out the electron configurations of your elements. But you have to know what the different regions correspond to, the S block, the P block, the D block, for instance. And that the row numbers correspond to your, or the period numbers correspond to your principal energy levels. All right, so let me just address another quick thing here before we look at a couple other examples. For the shorthand notation, okay, what we do is we locate the noble gas, which is a group 8 element that came directly before the element in question. All right, so if we go backwards from chlorine, so there's chlorine. If you go backwards, the group 8 element that came before it was neon. All right, so what we can do is just simply put neon in square brackets, Ne, and that accounts for all 10 of those electrons from neon right away. So then to account for the remaining 7 electrons, then we go 3s2 and 3p5. So 3s2 and then 3p5 would be the shorthand notation for chlorine, right? Putting neon in square brackets actually takes care of all of these 10 electrons. so you don't have to write it out. That's a shortcut. It's a shorthand notation. And if it's not specified in the question, when you write your electron configurations, if it doesn't specify shorthand or complete, you can use whichever one you're comfortable with. But if it says complete, then you have to start with the 1s2 and work your way across. If it says shorthand, then you use the group 8 element in square brackets. All right, let's take a look at another example. Get rid of all of this stuff on here. Okay, and let's do, we'll do it at the bottom. Let's do zinc. Okay, zinc is Zn. And the first thing you want to do is to locate it on the table. And zinc is right here. Okay, so atomic number 30 means it's got 30 electrons as well. All right, so we'll color code our table again. S block is in green. Our P block is in yellow. And our D block is in pink. All right, and then we have our period numbers. Period 1, 2, 3, 4, 5, 6, and 7. All right, so we're going to start at the top left with hydrogen right over here. We're going to work our way across. So 1s2 gets me to helium. Then 2s2 gets me to beryllium, Be. And then to get all the way across, we need to go to P now. 1, 2, 3, 4, 5, 6 gets me to neon. And then 3s2 to magnesium. And then all the way across to 3p, 1, 2, 3, 4, 5, 6 to argon. And then the next row, 4s2 to calcium. And now, in order to get to zinc, we have to go through the D block, all right, or the D area. And when it comes to the D is numbered one less than what the row number is. All right, so if the row number or the period number is 4, then the D, we would number it as 3D. And then we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to zinc. So 3D 10. All right, and that's the order in which those electrons are going to go in to our electron configuration. So the D is numbered 1 less than the corresponding period number. All right, so if the period number is 4, right, and we have a D row there, then it's actually numbered 3D. So that's a little wrinkle to it, and you have to be aware of that, otherwise you'll end up with the wrong thing. But as long as you know it, you have your electron configuration. All right, and then we can do our shorthand notation as well. Okay, so what's the group 8 element that came directly before zinc? If we go backwards from zinc, right, you always have to go back. It's actually argon, Ar, that comes, the group 8 element directly before it. So we can put argon in square brackets. That takes care of those 18 electrons, and then we go 4s2, 3d10. And that's your electron configuration using the periodic table, right? Putting argon in square brackets automatically accounts for these 18 electrons. And it is as simple as that. There are a couple exceptions to the rule in terms of filling the electrons. There's always exceptions to rules, but this is something you can always use as a really quick way to write your electron configurations.